Hello, everyone, and welcome to Graphing and Interpreting Linear Functions. Let's go ahead and hop into today's lesson. Before we get started, I want to go ahead and go through a few vocabulary terms with you. Go ahead and get your notes out. This is where you want to start writing, so you have these terms and you can study them. The first term is a linear function. A linear function is a function whose graph is a straight line. Self-explanatory. It is exactly a straight line. And as you're watching the video, remember you can pause this to stop and write down any directions as you need to. So that's a linear function. Slope-intercept form is the equation of a line written as the equation y equals mx plus b, where m and b are real numbers. M is your slope. Okay, so in slope-intercept form, m is your slope. B is your y-intercept. You need to have that memorized. Slope is the slope of a line, also known as the rate of change. I need you guys to remember that because you might, instead of seeing the word slope, you might see the phrase rate of change. So that's really important that you understand they're the same thing. Is the ratio of the change in y, the dependent variable, to the change in x, the independent variable. You guys are probably used to seeing it as m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay, that is the slope formula. You should have that memorized. It's going to be on your formula sheet, but you need to know how to use it. And that's what we're going to hop into today. So go ahead, pause the recording, write these terms down if you don't have them written down already. All right, here's some other terms. The y-intercept. The y-intercept is a point where the line crosses the y-axis. The y-intercept, written as an ordered pair, is 0, comma, y. Y is replaced with a number. So I'm given a coordinate plane. This is x. This is y. And say I put a graph on here. Okay. This, where it crosses the y-intercept, the y-axis, that's your y-intercept. And we would say 0, comma, whatever that number is. Okay? And that's how we do the y-intercept. The x-intercept is a point where the graph crosses the x-axis. So let me just go ahead and erase all that so I could draw it again. So the x-intercept is a point where the graph crosses the x-axis. So again, coordinate plane. This is your x-axis. This is your y-axis. Here's my graph. All right, so your x-intercept would be where it crosses the x-axis. And that is your x-intercept. Makes sense, right? Think of like intersections, intercepts. It's where it crosses the x-axis. And then the standard form of a linear function is ax plus by equals c, where a, b, and c are integers, meaning they're numbers, whole numbers. A and B are not both 0. A is positive. They like A to be positive. So that is standard form. Again, take a moment, pause the video, and write those terms down. All right, so let's hop to it. Let's talk about graphing linear functions in slope-intercept form. So here are the steps to graphing linear equations in slope-intercept form. Step 1, identify the slope and the y-intercept. Step 2, plot the y-intercept. Step 3, use the slope to plot another point. And step 4, connect the points to graph the line. Those are the 4 steps to graphing linear equations in slope-intercept form. Again, pause the video, write it down. Welcome back. And you see the steps again in case you did not get to write it down and did not pause the video. All right, so let's go ahead and get started with this part. All right, so it says graph. They want you to graph y equals negative 2 over 5x plus 3. So step 1, we want to identify the slope and the y-intercept. In case you forgot, in the last slide, remember slope-intercept form is y equals mx plus b. Well, that comes in handy because we can see exactly where m is. M would be negative 2 over 5. We do not say the x, we leave that separate. So m is negative 2 over 5. B, which is your y-intercept, is 3. So we identified the slope. M is negative 2 over 5. B is 3. So that's step 1 complete. Step 2, plot the y-intercept. So the y-intercept is on the y-axis. The y-intercept is 3. So I'm going to put a dot at 3. That's step 2. Step 3, use the slope to plot the other point. So our slope here is negative 2 over 5. That's our slope. So remember, our slope tells us rise over run. If you did not remember that, write that down. Slope tells you rise over run. Now, because it's negative, I'm going to put the negative with either the top or the bottom. I'm going to put it with the top. When it's negative, that means I'm going to go down. So let me just go ahead. When you have your rise over your run, if the top number is positive, that means you're going to go up because that's the rise. If it's negative, that means I'm going to go down. All right, the run, if it's positive, that means I'm going to go to my right. If it's negative, that means I'm going to go to my left. Okay, so make sure you write that down. All right, so our slope is negative 2 over 5, so I'm going to go down to 1, 2, and it's positive 5, so I'm going to go to my right 5. 1, 2, 3, 4, 5, and I'm counting. Okay, so I have to do the rise and then the run. Okay, and then, so that's step 3. And then step 4 is connect the dots. Okay, I'm going to go ahead and use my straight line feature and connect the dots, kind of like what you did when you were kids. And that's how I graph y equals negative 2 over 5x plus 3. All right, go ahead and write that down in your notes. Write down any helpful hints that you need. All right, so let's try another one. All right, let's graph y equals 3x minus 2. Y equals 3x minus 2. Now, in this case, you still need to identify your slope and y-intercept. So y equals mx plus b, as slope-intercept form. My slope in this case is going to be 3. It's a whole number. My y-intercept in this case is a negative 2. I'm going to keep that, whatever that sign is to the left of it, keep it with it. That's a negative 2. All right, so even though it says minus 2, that's a negative 2. All right, so we identified the slope and the y-intercept done. We've got to plot the y-intercept. The y-intercept is negative 2, so I'm going to go down to negative 2. There we go. That's done. Now I'm going to use the slope to plot another point. My slope in this case is 3, but it's a whole number. I need a fraction because I need it to be rise over run. So how do you turn a whole number into a fraction? Well, we put it over 1. So that means my rise is going to be 3. My run is going to be 1. So I'm going to go up 3, 1, 2, 3. Then I'm going to go to my right 1. And I'm going to plot that. So I used my slope to plot the other point. And then my last step is to connect the dots. And there you go. Now, what's different between this problem and the last problem? In this problem, our slope was a whole number, right? And we had to put it over 1 so we can have a fraction so we could graph it. All right. So now it's your turn. Go ahead and pause this recording and try it out yourself. All right, welcome back. I hope you paused the recording and came back, and now you're going to try it with me. Okay, so let's go ahead and do this one. So it says graph y equals 3 over 4x plus 5. So again, identify the slope and the y-intercept. Your slope, remember, y equals mx plus b. Okay, so your slope is going to be 3 over 4 because that's where our m is. Remember, we do not include the variable. And our y-intercept is going to be 5. I hope you guys got that same slope and y-intercept. Step 2, plot the y-intercept. So my y-intercept is 5. So I'm going to plot my y-intercept at 5. Okay, and then use the slope to plot the other point. Now, I hope you guys have graph paper. I should have mentioned that earlier, but use your graph paper. So our slope is 3 over 4. That means my rise over run. Now, this is going to take me off the table, right? I could also do the opposite. If I have -3 over -4, isn't a negative divided by a negative a positive? So if I make them both negative, I can stay on the table. Okay, but if that's a little bit too much, just go ahead and add, add a little bit more. So I'm going to have to go up 3, 1, 2, 3. And then I'm going to have to go to my right 4. 1, 2, 3, 4. But I could also go down 3, 1, 2, 3, and go to my left 4. 1, 2, 3, 4. And it actually will still be on the same line. So if you're ever off the grid and you're like, I don't know how to do this, you can go backwards. Okay, make them both. If it's positive, you have to make them both, negative. Not just one. You have to make them both if it's positive. Okay, because a negative divided by negative is a positive. Okay, think about why that works. And we did the last step, which is connect the points. And there you have it. Now, there is a resource that you guys can use. You can use your Desmos graphing calculator. Okay, so you can use your graphing calculator to graph this. So if I was to put this in my graphing calculator, I would open up my keyboard. I would say y equals 3 divided by 4. Make sure I come out of my denominator and say x plus 5 and graph it, and it should match. Yes, you can use your graphing calculator, but the reason why you need to make sure you can do it by hand is because sometimes your graphing calculator will give you decimals, right? And you need to be able to find the next point. 4,8, right? So the graphing calculator, you can use that to help double check your work, but you still need to know how to do it by hand. All right? Hope you guys got that your turn, and that it all made sense. So that was graphing linear equations using slope-intercept form. Next time, we're going to come in and we're going to talk about how we do it with real-world problem situations and also doing it in different forms.